Hello, geometry students. Today is going to go super fast. There are only 6 examples and they're pretty self-explanatory. So just bear with me and we'll keep going. So we're talking about congruent chords and arcs today. Remember, a chord is a segment that just cuts across a circle. Doesn't necessarily go from the center, but it touches the circle in 2 places. We can say that 2 chords are congruent if and only if their intercepting arcs are congruent. So in this one, AB is congruent to DC if and only if arc AB is congruent to arc DC. So these segments are congruent if and only if these arcs are congruent. And then the second theorem we're going to talk about is if they are equidistant from the center. And the way that you can tell this is that these two little segments here are congruent. So if FE is congruent to EG, then segment AB is congruent to segment DC. And the same is true like the other way. So you can say if the chords are congruent, then the arcs are congruent. If the chords are equidistant, then the chords are congruent. And if the chords are congruent, then they're equidistant. And finally, we're going to talk about this little perpendicular thing right here. So if a diameter or radius is perpendicular to a chord, and that means we got 90-degree angles going on here, then it bisects the chord and its arc. So that means that these two little arcs are congruent and that those two pieces of the chord are congruent. So if EG is perpendicular to DC, then DI is congruent to IC, and DG is congruent to DC. Okay? So basically, you're going to use all of this to set things equal and solve. So on this one, we know that this is congruent to this. So this arc is the same as this. Congruent is the word of the day, and congruent means equal, right? So we are always pretty much going to be making things equal. So you have to remember that. So congruent is the word of the day. Congruent, equal. So those chords are congruent, so we're going to set the 115 equal to the 7x plus 24. 115 equals 7x plus 24. So we get 91 equals 7x, so x is 13. Same thing here. They've marked the chords congruent, they've marked the arcs congruent, so the chords are congruent. So 18x minus 2 equals 52. So 18x equals 54. So x is 30. Now, these we have to take one step further. So they've marked our arcs congruent. They're pointing out that the chords are those, so we're going to set them equal. 9x minus 34 equals 4x plus 1. 5x equals 35. So x is 5. If x is 5, to find xy, we're going to plug it in here. 4 times 5 plus 1 is 21, and we're done. Notice again, we're just setting everything equal. So here, those chords are congruent, therefore the arcs are congruent, so these are the same. So we have 11x minus 72 equals 5x plus 6. 6x, woo! 6x equals 78, and x is going to be 13. 13 must be that magic number today. Okay, now, this next one is a little bit more involved. So we have that these chords are congruent. And that means that these arcs are congruent, which means that, oh, I accidentally touched Explorer there, that to find this, we kind of have to take into account that this piece is 76. So we're going to do 360 minus 76. Go into my best friend Desmos here. Doing a little bit of algebra 2 in there earlier. So 360 minus 76. That gives me 284. So that means that these two arcs together are 284. But we know that those arcs together are congruent. So we can take this and divide by 2. We get 142 for each of those arcs. So this one's 142 and this one's 142. So if this arc down here is 142 and it's also 6x minus 20, after we found that, we can set those equal. So 142 equals 6x minus 20. 6x equals 162. And x is going to be 227. There you go. Okay, finally, this says that MP is 5x minus 34, and that PN is 2x minus 4. And again, we're going to set those equal. So 5x minus 34 equals 2x minus 4. 3x equals 30, so x is 10. But we're not done because we actually have to plug it back in. So 5 times 10 minus 34 is going to be 16. So there it is. That is the end of our little tiny place with chords. So hopefully that made sense and it was short. And so you'll have lots of time to work on that worksheet that I left.